What if I told you your home router is secretly using NAT Overload right now? This invisible technology is why your whole family can browse the internet through a single public IP. But here's the problem. Most network engineers struggle with NAT types. In this video, I'll break down Static NAT, Dynamic NAT, and PAT Overload with live router demos that finally make sense. Watch as we configure each type and reveal which one Fortune 500 companies use most. The three types of NAT. On this topology, we will see how the router will translate a private source address into a public address with Static NAT. The PCA, which bears the IP 192.168.0.1, wants to communicate with the web server that is behind the internet and which bears the public IP 2.21.107.150. The packet will arrive at the router, and the router will check its NAT table. As the router finds a match in it, it will replace the internal local source address of the PC, i.e. 192.168.0.1, with the global address translated into 218.15.20.2. This address is the public IP of our router, which allows you to surf the net. Once the translation is done, the package will be sent. Then, the web server will receive the package from PCA and will respond to it using the public IP of our router as the destination address. So, this is the internal global address, and when the router receives this feedback from the web server on its external interface destined for the inside global, it will consult its NAT table again and translate the inside global into inside local before transmitting the packet. The communication between PCA and the web server works correctly through the internet using Static NAT. Static NAT is a one-to-one mapping between an internal address and an external address. We can compare the internal address to that of our PC at home, and the external address is the public IP of the internet box, the one that allows you to surf the internet. Static NAT also works in reverse. For example, you can map an internal global address to a local one, very useful for a web server. Now, let's move on to its configuration, which is relatively simple. To start, on the router, we will configure the public IP on its interface on the internet side, and we will tag the interface with the command IPNATOutside to tell it that it is well connected to the outside on the WAN side. Then, we configure an IP on the interface connected to the local LAN. We take 192.168.0.254, which will be the default gateway for our PCs. And don't forget to tag this interface as inside, because it's on the LAN side. And finally, in global configuration mode, all that remains is the IPNAT inside source static command to tell it to translate the internal IP 192.168.0.1 into the external IP 218.1.115.20.2. To check the router's NAT configurations, you need to use the show IP NAT translation command. With this command, you will find the Cisco terms, which we saw in the previous course. What's in blue are the port numbers. Port 23 is the default port for the TCP protocol, and the digit 1021 is a random port number that is used to mark the packet. Static NAT allows for a permanent mapping between an internal address and a public address. It's a one-to-one translation, and Dynamic NAT makes it possible to translate private IPs to public addresses that come from an IP pool. Its configuration differs a bit from Static NAT, but there are still a lot of similarities. As with Static NAT, each interface must be identified as an interior interface, called inside or outside, and then, rather than creating a static map of a single IP address, the translation will be done on a global internally addressed group. To see how the dynamic NAT works, we will base ourselves on the same topology and analyze the different steps. Here, the two PCs on the left, which carries a private IP, wants to communicate with the web server on the right, which has a public IP. If there is no static NAT configured, then the router will dynamically translate the addresses of the two PCs. Because if both are configured, the static NAT will always take precedence over the dynamic NAT. Here, the router selects a global address from a group of IPs that has been created, and it will do the translation. He chose the IP 218.115.20.1 for the PCA and the .2 for the PCB. The mask of our public network is a /27, so you can use the IP range from 0.1 to 30. 0.0 is the network address, and 0.31 is the broadcast address. These are two addresses that we cannot assign to hosts. The router therefore replaces the internal local source address of the two PCs with one of the translated global addresses and sends the packet. This way, the web server can receive the data without any problems. And if they want to respond to them, then it will use their own global internal destination addresses. And when the router receives the packets with the internal global IPs, it will look up the translation in its NATable and will transfer the IPs again before transferring them to the PCs. The communication between the web server and the PCs works properly. Let's take a look at the dynamic NAT configuration. First of all, you have to start creating an access list to designate the network you want to translate. Here, it will be the 192.168./24 network. Next, you need to define the IP address group with the command IP_NAT_pool. Instead of the name of the pool in blue, you have to choose the name you want to give it. In the example, we will use the entire public IP range, a total of 30 IPs. These two commands are to be done in the global configuration mode. The ACL should only have permissions for the NAT, because if at the end of the ACL you make a permit any, which allows all packets, then the NAT protocol will cause a lot of consumption of router resources, which will cause a lot of problems on the network. As a reminder, at the end of each ACL, there is implicitly a line that we do not see, which is a deny any. As with static NAT, don't forget to tag our input-output interfaces. As a reminder, the IP_NAT inside command marks the interface as connected to the inside network, and the IP_NAT outside marks the interface connected to the outside network. And finally, still in global configuration mode, you need to establish the dynamic translation of the source IPs by specifying the ACL and the address pool with the command IP_NAT inside. And as with static NAT, the show IP_NAT translations command allows you to display active NATs. One of the main forms of NAT is PAT, which is also called overload. Here, multiple internal local addresses can be translated using NAT into one or more internal global addresses. Most home internet boxes work in PAT. The internet service provider assigns an address to the box, which works like a router, and several people can surf the internet from a single address. With PAT, multiple addresses can be translated into one or more addresses using a port number TCP or UDP that will be assigned automatically and randomly on each private address. On this topology, both PCs use the same public address to communicate with the web server. These are the TCP port numbers, which differentiates the packets from PCA from PCB. With this system, many internal hosts can share the same internal global address using many port numbers. For the configuration of the PAT, and like any kind of NAT, you have to tag our input and output interfaces. Then, as with dynamic NAT, an access list must be created to define the local addresses that can be translated. And finally, we have to tell the router to translate our access list through our output interface, Fast Ethernet 01, with the command IPNAT inside. Don't forget the little word overload at the end of the order. And as with all NAT types, the verification command is identical. It's show IPNAT translations.